Imagine yourself floating in the endless expanse of space. There's no up, down, left or right, no edges or corners. It feels like being lost in a galactic wilderness, where there's no reliance on natural reference points or even a usual sense of direction. Without gravity, you might find yourself spinning and tumbling in all directions, as if caught in a cosmic tumble dryer. So how do you navigate? How do you keep from getting lost? On Earth, we often take direction for granted. Picture yourself hiking through a dense forest, surrounded by towering trees, mossy rocks and chirping birds. There are no clear paths or road signs. So what do? The first thing that comes to mind is probably a compass, a small, magical device that always knows where north is, thanks to a tiny magnet inside. It senses Earth's magnetic field, which covers our planet like a cozy blanket. Once you know where north is, you can easily determine east, west and south, and navigate like a seasoned explorer. This is what we call a reference point. Reference points are more than just helpful for hiking. We use them in our daily lives. Whether it's giving directions, using a GPS, or telling someone which way to turn at a street corner, reference points keep us oriented. Even in the skies, they guide us. Imagine you're on a thrilling hot air balloon ride, soaring above breathtaking landscapes. How do you know how high you are? That's where sea level comes into play. A universal reference point for measuring height. As you rise in the balloon, instruments like altimeters help measure your altitude relative to sea level, just like a ruler showing how far you've climbed into the sky. This concept is widely used in everything from aviation and geography to meteorology. But when we leave Earth and head into space, things get more complicated. In space, there are no natural landmarks, compasses, or universal altimeters. Determining direction without any fixed points of reference becomes a real challenge. Even stars, which we use for navigation on Earth, can be misleading in space, where they appear to shift as you travel. So how do we find our way in the vast expanse of the cosmos? Spacecraft rely on advanced technology and precise calculations to navigate the galaxy. One of the most remarkable tools they use is the star tracker, a kind of cosmic GPS. These cameras scan the night sky, capturing images of stars to use as reference points, much like how we use street signs. To stay on track, spacecraft also use gyroscopes, which act like space compasses. These incredibly sensitive devices detect even the slightest changes in orientation, helping the spacecraft maintain stability. Cameras and lasers are also used to measure distances to nearby celestial objects. Behind the scenes, spacecraft have powerful onboard computers that perform complex calculations to determine altitude, speed, and trajectory. In space, altitude takes on a whole new meaning. Instead of measuring height from the ground, altitude is often calculated based on a spacecraft's position relative to a nearby celestial body or its orbit. For example, astronauts aboard the International Space Station might refer to their altitude as the distance from Earth's surface, even though they're still within our atmosphere. When celestial bodies don't have a solid surface, like Jupiter, which is mostly gas, things get trickier, but we find ways to measure nonetheless. In addition to all this technology, space agencies act like interstellar traffic controllers, ensuring that spacecraft from different nations don't crash into each other. They rely on standardized systems and conventions, like the right-hand rule used in physics and engineering. This handy trick helps us understand direction, force and motion. Space exploration challenges our perception of direction and orientation, reminding us of how much we rely on our home planet for reference. Who knows what incredible methods will develop in the future? From quantum navigation to warp speed technology, making space travel not only practical but inspiring.